Muscle contraction, sliding filaments. These thick yellow filaments are representing myosin. These thin green filaments are actin. This is at rest. This is in contraction. Notice the overlap. How do we get from here to here? Let's take a closer look. This is the actin filament. It is wrapped by what's called tropomyosin, this red filament here. And then we see troponin as well, these little pink structures here. This is the myosin filament. These red stars are representing adenosine triphosphate, the universal energy molecule. Notice the myosin heads are attached to ATP, adenosine triphosphate, before the overlap. Here, calcium, which is represented by this green bubble, has now bound to the troponin. The tropomyosin rotates off of the active sites. The myosin heads then use the ATP in binding to the actin and pulling it. And that's why we see this overlap here in what's called a power stroke. And notice the myosin heads are no longer bound to the ATP. After the contraction, when it resets, it'll then bound to the ATP. Let's look at it with the labels. Myosin, actin, tropomyosin, troponin, ATP. Calcium binds to the troponin. The tropomyosin rotates off of the active sites. The myosin heads bind to the actin, and we see that power stroke using the ATP. And then after the power stroke, then in the reset, the myosin heads will then bound to the ATP. Let's review without the labels. Myosin, actin, tropomyosin, troponin, adenosine triphosphate, ATP. Calcium binds to the troponin. The myosin or tropomyosin rotates off of the active sites on actin. The myosin heads bind to the actin, and there's a power stroke. When that's completed, then the myosin heads will bond to the ATP, preparing for the next contraction. Thank you for joining me.